Hello again. So a while ago I made a video about the 24 cell and I used this model here. And now that I've completed the magnetic version, I will try to explain it a bit better and a bit more in detail. And we will actually explore how the puzzle might function. Let's look again how the puzzle is constructed. It uses these two colored pieces, and the whole puzzle is constructed like this. We here have a white cell, and next to the white cell we have here a green cell and a blue cell, and you can see the corners of this white cell. They match up with this cell. Then we have here the purple and the pink cell, and on top here we have the red cell and the orange cell, and then we have opposite the white we have the yellow cell. And here we have a tesseract shape. And if we rearrange this a bit, we can take half of the blue cell here and put it there, one half of the pink cell, and it matches up here. The purple cell matches up here. We have the red cell here and the orange cell here. And now we have split up the tesseract here in two identical, almost identical pieces. And the only thing that's left are these cells at the corners. You can see that some pieces are missing here. And let's look here. Here we have the remaining pieces. I also already put them in the correct order. So here we can complete the, what is that color? This cell here. Then we have the purple with lines. We can complete it here. And then we have orange is here. We complete it here. And then we have yellow with stripes. We have here. Okay. And the same we have to do with the other side. So now you can see the puzzle is complete and the colors match up. So if we look at some single pieces here, this piece here, it has an orange and the sand color, and this piece can be in this position or here. So you can actually transform all these pieces which are here in between the two cells. You can switch them from here to here if you want. So you can actually transform this puzzle a bit. Like, for instance, here the green cell, which was split up before, we can put together with this opposite piece. It's this one. This opposite we can put here. And now we have completed the light green cell here, which wasn't complete before. Before it was more split up, like here the purple cell before. So why is it possible that these pieces are in between this? If we look at the geometry of the 24 cell, then this piece or these two cells, they are actually in between the orange, green, and the white cell on the inside. Now, instead of looking at the moves or twists first, let's start with looking at gyros and how they work. This move here, that's just a normal reorientation. You can see other pieces are on the outside. You get the red on the inside, for instance. And this doesn't change which colors are here in this position. And there is one way to reorient the puzzle so that instead of the white and here the yellow cell are the opposite here, you can change it so that, for instance, the red color and the orange are on the inside. And this is actually quite straightforward. You take half of the white cell here and put it on the opposite side, and thereby you complete the orange cell here. And now you have to do a few moves, but they are all the same. Here you see you have always these three pieces. Here, these three, and these three pieces. And all you have to do is to reorient them like this. You put this here and flip this over and put it here. And you can do the same on this side, just in the opposite direction. You put this here and flip this one over, and this one here, flip it here, put it like this and flip it over, and this, like this, and flip it over. And now we have completed one side, and you have to do this on all the other sides, which I will do here now. So now we have completed the first gyro, and as you can see, the puzzle is the same as before concerning the shape, but now instead of the white and the yellow on the inside, we have the red and the orange on the insides of these two halves. And you can do this transformation in to all the other cells. So for instance, I could gyro it to the blue and green cell. So I just have to split up the red cell, put the half here, and then transform these L shapes as I did before. This is the first gyro. Obviously, this first gyro only gives us access to 8 cells of the 24 cell. So what about the others? So what about the cells which are at the corner positions here? And this is a bit more complicated. We have here completed the purple cell, for instance, here. And what we need to do is take it out. Wait. So now what needs to happen is these 4 corners, they need to rotate in this direction, so counterclockwise. And you have to do this with all 4 on this half. Rotate them like this, and then we are left with these pieces, and I will show you. So how would we rotate these pieces? There are actually different ways you can do it, but one way is to just do it like this. You can switch these two, then switch these two, and you remember which one was on the inside, and then again switch these two. And what this did is it rotated, it put the piece, the white piece was in this position first, now it's here. The red was here, now it's here. the seafoam color was here and now it's here, and the green was here and now it's here. So and next we do it with the opposite side here. Now we have the orange striped cell, and here we have to do it in the other direction. So here, instead of starting on the right, we can start on the left side. So here we switch these two, then switch these two, and switch these two. And now, as you can see, these two cells we've created here, they fit together like this. Yeah? And now we have to do it with the other two cells here. So now we have created the first one of these cells, and you do the same on the other side, and you will have these cells left. So I will do this next, the same as before. So now that we've finished making the cells, we have these two actually fit together like here, and now we have again the same as the beginning with our tesseract shape, and again we can split it up like this, and this piece can roll here and here. This piece can split up like this. This one rolls here and splits up here, and this one splits here. And now, as you can see, we have again the shape from the beginning with only the cells in the corner that are missing. So, and for the missing corner cells, you can see here are the last ones, but it's not correct to just put them here. You have to see, you see yellow is not one of these, so this is actually the corner which is opposite this position. So you have to switch it up like this, and then you can connect it to the other side. Next here is the blue one. So now you can see we have completed the second gyro, and as you saw, it was a lot more complicated, but now the white, orange, red, and so on, the cells we had in the beginning on the inside, now they are all on the outside, and we have different colors on the inside. I think this gyro is of course a bit what is in the hypercubing community referred to as sticker soup. So I'm not sure if that's a workable puzzle, but that's a thing you can do. So what about twists? This is actually also a complicated topic, and there are two ways to do this if you look at some virtual puzzles. And one is cell turning and the other is vertex turning. So let's look at cell turning first. This is a half-cut puzzle, so in reality half of the puzzle should be moving when you make a twist, like this. Yeah, so this could theoretically be a twist, or this, for instance. So the the cells don't match up. But there's a problem because as I showed before, you could also reorient the puzzle like this and put the cells together like this here, since these pieces are actually in both positions at once, like Schrödinger's pieces. And now we see this last piece in the corner position. It was for the blue one before. Let's make it like this. It should be here. This is how it's put together. If you put this corner piece here, again, it's in both positions at once. So it makes a difference if you put it here and make the twist, or if you put it here and make the twist. And if you look at the virtual puzzle, this problem is also is the same, and the virtual puzzle actually splits up these pieces, and the virtual puzzle has one colored pieces instead of two colored pieces. So it doesn't. It works in a way, but I think it's a bit problematic. So one way to do a twist in a half-cut way is to put all these corner pieces on one side, like here. This belongs here, and this one we can put here. And now all the corner pieces are on this side here, and now we can make a twist, and we can do a twist that's using the long diagonal. So we can make this twist here and then put the pieces back to where they belong. That's one way to make a twist with the half-cut puzzle. And so it's a bit of a cheat, but it's one way to do it. So what's the other way? Instead of cell turning, we can do a vertex turning puzzle. And the pieces that are turning, we can look at it like here. There are 12 pieces that are turning, and it's this half cell here, and the adjacent pieces. And the half cell on the inside here. So these pieces are turning together. It's a bit hard to get it out. It's the one half, and the other half. Maybe there are better ways to put it to get it out. So this is these are the 12 pieces that are twisting. So what you can do is make a twist like this and simply put it back together. So, and then the vertex that's between these two cells, between the orange striped and the light purple, this is the vertex that has turned. So, and the other way you can do is instead of turning it from this direction, you can actually turn it this direction also in a way. And what you have to do is you have to again change the position of these pieces. This one needs to be here. So you can put this here and this one here. And on the opposite side, you have the same. I'm going to put this here. So these are what's left. So and you have to put this here and this in this position. So this one. This one is here, and this one here. And then you can see these two match up. And this is the rotation that is going on. You rotate these like this, and these pieces, they have to move the same. So you also have to switch these up, that they make one rotation. So if you make one rotation like this, these pieces also need to rotate in this direction. And you can do the same as before with the second gyro. You switch these pieces, then you switch these two pieces, and then you switch these two pieces. And now you have to put these back together as they were before. So this piece was in this position, like this, and this was here, and it can be put together here, and this one was here, and the red one was down there, so we can put the red one here, and the white one here, and now it did one rotation around this axis here, and you can put it back together. So as you've seen now, this puzzle is, even in the magnetic version, very complicated, and I don't think anyone will ever solve it or scramble it, but it's still a nice proof of concept that 24 cell is possible. So thanks for watching, see you next video.